Autotransformer reduced voltage starters. In this presentation, we're going to be looking at how an autotransformer RVS system functions, as well as some of the different variations in the system design. Autotransformer reduced voltage starters can be used with any three-phase motor. And what makes them unique is that the line side current of the autotransformer starter is always lower than the load side current when the motor is starting. Remember, it is a transformer. Open delta is one configuration that we can use with autotransformer starters, and these are inherently open transition. A Y autotransformer starter is inherently a closed transition. An autotransformer starter reduces the line voltage across the motor at start. So here's an autotransformer starter operation where we have a tap setting on the autotransformer, and let's say it's at the 75% tap, and we have a 208 volt supply voltage. The start contact is closed. It allows current to flow through to the motor and a reduced voltage at the motor. Lower voltage means lower starting current and lower starting torque. But remember what we said, the value of current is actually going to be lower on the line side, so the supply side, when compared to the load side, the motor side. And that's because this is a transformer. And although very simplistic in this diagram, we can appreciate that there is more connections in the three-phase operation of this system than simply a single line traveling from left to right. If we were to look at a basic single-phase diagram of an autotransformer, we can see here that 100 amps on the motor side will render a lower voltage on the supply side, and that's because we're utilizing the percent tap. The percent tap can be applied to the load motor current, and this will then determine the amount of line side current, and the higher voltage, obviously, then also leads to a lower current. We will have a tutorial specifically on this calculation. Today, or in this presentation, we're only going to be looking at the operation. So the transition from start to run is slightly different for Y and for open delta systems. Closed transition is a Y system, and there are 3 autotransformers. Open delta is open transition, and there are only 2 autotransformers. Here's an open delta autotransformer motor starter. And in this situation, again, we have a time delay relay, and it's a time delay on energization. We'll energize the system and press the start push button. Immediately, TR and S energize. TR is our timing relay, and it's important to understand that at times, timer relays also have instant contacts. In this situation, the TR relay has a set of instant contacts, so contacts that change state immediately, that are being used as the holding contact for the control circuit. All of the S contacts now change state as well, and we see that we have a full holding path as well as a motor that is now energized. The motor is starting, and it's starting at a reduced voltage, and we see a slightly smaller current on the line side than we do on the load side of this motor starter. Now, the timer relay is counting down. It continues to count down until eventually it reaches its final value. And once that happens, the timer contacts will then change state. And so there are 2 of them in this circuit. They both change state at the same time, and this causes a change in what is going to take place with the power contacts. So now the S coil will have to de-energize. And notice on the bottom, this S contact is an electrical interlock, a fancy word of saying this coil controls this contact, meaning R cannot be energized until S is de-energized. So contacts go back to their original state all across the board. This now leaves the motor in an open transition, which means there is 0 volts being applied to the motor. At this point, since the S contacts have returned to their original state in the control circuit, we now have a path to the R coil, and that is the run coil. The contacts change state, and the motor is now in run step. So this is a 3 separate steps of start, transition, and run, and open delta is an open transition starter. A Y autotransformer motor starter is a little bit more complex, but again, only one timer relay. So the timer relay is the same form as the previous in that there are instant contacts being used for the holding contact, and there are timed contacts being used in the power circuit and the control, or sorry, just in the control circuit. So we'll press the start push button. We energize both TR and 1S, and we're simply following through the schematic to see where I have a direct line and what would be energized. Immediately, the instant contact for TR will change state and the 1S contacts will change state. So here are all of the items that are going to be controlled and change state. There we go, they change state, and now our timer relay starts to count down, and we'll notice that after 1S has energized, we now have a star point. So that means the autotransformer is now in star. You'll also notice that the 1S closed a set of contacts at the very bottom of this control circuit, and this will now allow for 2S to be energized, a fraction of a second after 1S was. 1S now energized causes all of the, or sorry, 2S now energized causes all of the 2S contacts to change state. There are some in the control and some in the power circuit, and this now causes the motor to be energized at the reduced voltage from the Y autotransformer. Now remember, this timer relay is counting down, and as it counts down, we're eventually going to reach a completion time, at which point both of the timer contacts will change state. So there are two of them, and we'll see at the bottom that one of them is right now allowing 1S to remain energized, and the other one is not yet closed. So there we have it. The top one closes, the bottom one opens, and now our 1S coil is de-energized. And that means that all of the contacts that it controlled are going to revert back to their normal state. And this breaks the Y connection in the power circuit and simultaneously allows for the R coil to be energized in the control circuit. R coil is energized, which means now all of the R contacts are going to change state. And all of the R contacts, there are 3 in the power circuit and 1 in the control. Notice what it's going to do. It's going to take a split second for us to energize this relay and for the contacts to change state, causing the main motor to now be energized with the full voltage. And now, because 2S has been de-energized, all of the 2S contacts will now revert back to their original state or normal state. And this effectively removes the entire autotransformer from the control circuit. At this point, the motor is now in full run condition. And in this way, a Y autotransformer motor starter has a closed transition from start to run by having the autotransformer connected into the circuit, disconnecting the Y connection, and then fully allowing the full voltage power circuit to be connected across the motor terminals at the very end. A autotransformer motor starter will typically have a large 3-phase autotransformer mounted in the cabinet or beside it, and it's beside often on larger systems because of the heat generated by the transformer.